Hey everyone, welcome back to our deep dive into Solid. Today, we are kicking things off with the S, the single responsibility principle. And let me tell you, this is probably the biggest reason our code bases turn into a total mess. So yeah, let's get right into it.
All right, let me ask you something, and I'm pretty sure I know the answer. Have you ever opened up a file and just kept scrolling and scrolling? You've stumbled upon one of those monster classes, right? That infamous user manager or order processor that's somehow responsible for, well, everything.
Yeah, we've all been there. It always starts out so simple, so innocent. But then a new feature gets tacked on, and another one. And before you know it, this one little class is talking to the database, it's generating PDFs, it's sending out emails. Heck, it might as well be brewing coffee for the team. It's become a complete code monster. And this monster creates some very specific problems, what the pros call design smells. Your code becomes rigid. You know, where a tiny simple change over here ends up forcing you to make a dozen other changes all over the place. It also gets super fragile. Like, you fix a tiny bug in a report and all of a sudden the payment gateway stops working. How does that even happen? And finally, it's immobile. You can't just grab a piece of that class and reuse it somewhere else, because it's all tangled up. It's just a complete mess. So, the big question is, how do we fight this thing? Well, it's all about changing how we think about our code. And I've got the perfect analogy that's going to make this crystal clear. Okay, check this out. On one hand, you've got a Swiss Army knife. Super cool, right? It does a bunch of different things. But here's the problem. What if you want to upgrade the screwdriver? You can't just swap it out. You have to mess with the entire tool, and you might just end up breaking the bottle opener in the process. Now, on the other hand, you have a toolbox. It's full of dedicated, single-purpose tools. If you want a better screwdriver, you just buy a new screwdriver. The hammer and the wrench, they don't care. They're completely unaffected. See? The changes are isolated and safe. And that's the whole point right there. This is what we're aiming for. Our classes should be those individual tools in the toolbox, each one a single, sharp tool designed for one specific job. We want to avoid building those messy, do-it-all Swiss Army knives. Okay, so let's take that toolbox idea and turn it into the actual formal principle, because this concept of a single job has a very precise meaning when we're talking about code. And here it is, the Single Responsibility Principle, or SRP. It says that a class should have one and only one reason to change. Now that phrase, reason to change, is everything. A responsibility isn't just about what a class does. It's about who or what would ask for it to be changed. Think about it. If a request from the database team and a request from the marketing team make you edit the same class, then you've got a problem. That class has way too many responsibilities. And this is the classic definition from the man himself, Robert C. Martin. It's simple, but it's powerful. And that focus on the reason for the change, that's where all the magic happens. All right, theory is great, analogies are fun, but let's see some code. It's time to get practical and actually refactor one of those classic Swiss Army knife classes I was talking about. So here's our starting point, the before picture. Take a look at this user processor. Come on, you've seen this class before, right? It's doing database stuff, it's exporting data to JSON, and it's sending welcome emails. That's three totally separate concerns all crammed into one place. So what's the big deal? Well, this class now has three different reasons to change. If the database team changes the schema, you have to edit this class. If the product manager wants a new field in the JSON export, you have to edit this class. If marketing wants to tweak the welcome email, guess what? You're back in this same class again. You can't touch one part without putting the other two at risk. And now, the after. Look at this. We've taken that one big blob and broken it up into our toolbox of clean, focused tools. We have a user repository that only deals with the database, a user serializer that only knows about JSON, and an email service that, you guessed it, only sends emails. Now, if the database schema changes, you only touch one tiny predictable class. Isn't that so much better? Okay, so we've done the work, we've cleaned things up. What's the real payoff here? Like, why should you actually bother doing this on your projects? Oh, the benefits are massive. First, you get what's called high cohesion. It's a fancy way of saying that everything inside a class actually belongs together. Your classes are instantly easier to understand. No more 2,000-line monsters to decode. And testing?
it becomes a dream. You can now test the email service all by itself without having to spin up a database. That is a total game changer. And maybe most importantly, your code is just so much easier to change. The risk of accidentally breaking something totally unrelated just plummets.
And I really want to hammer this point home. High cohesion, that's the goal. We want our classes to be these clean, logical, self-contained units. So SRP isn't just some arbitrary rule you have to follow. No, it's one of the most powerful tools we have to actually achieve that beautiful, maintainable code we all want to write.
So from now on, whenever you're about to create a new class or you're looking at some old code, I want you to ask yourself that one question. Is this a sharp tool or is it a messy Swiss Army knife? Is it doing one thing well or is it a tangled mess just waiting for its moment to break? Speaking of messy, I want to hear from you. We've all seen them. What is the absolute worst, most ridiculous God class you have ever had to deal with? Drop your horror stories in the comments below. I'm genuinely curious. And hey, we can all share in the pain together. All right, that's a wrap for the S. Next time, we are tackling the O in Solid, the open-closed principle. And get this, we're going to learn how you can add brand new features to your system without ever changing a single line of existing code. Sounds impossible, right? Well, you'll have to subscribe so you don't miss it. I'll see you in the next one.